All right, this is lesson 8.5, the properties of trapezoids. So first things first, what is a trapezoid? I like to think of a triangle when I'm thinking about a trapezoid. And the way that this works is with our triangle, we know that we have one base. If I create a line inside of the triangle that is parallel to the base, and I could just kind of connect the endpoints of those parallel bases, I have now created a trapezoid. And the main thing here is that only one pair of sides are parallel. Okay, so you can see like the right side is going downwards to the right, the left side is going downwards to the left. So those sides are not parallel, just the top and bottom are. Now, what is an isosceles trapezoid? An isosceles trapezoid has the same shape, but the main thing is that the base angles are the same. So base angles are congruent. Therefore, if the base angles are congruent, that would make the left and right side also congruent. So therefore, the left and right side are congruent. All right, we'll see that in a couple of examples moving forward. All right, so the first theorem, if a trapezoid is isosceles, then the pair of base angles is congruent. Okay, so we can see A and D. So angle A is congruent to angle D. And then as well, the top base angles B and C, angle B is congruent to angle C. Next theorem, if a trapezoid has a pair of congruent base angles, so we see that here with A and D, then it is an isosceles trapezoid. So that means the side AB and the side CD are congruent. And the final one, trapezoid is isosceles is if and only if the diagonals are congruent. So we see B going to D and A going to C. Those would be congruent since they are an isosceles trapezoid. Flip the page and let's check out our first two examples. This says find angle N, L, and M. So the other three angles based off of this 50 degrees. Now I see the left and side are congruent, which means that this is a isosceles trapezoid. So I know this is a 50-degree angle as well. So the first one, angle N, is 50 degrees. Now let's remember our consecutive angles. I know that if these two sides are parallel, then the consecutive angles, you might have learned this as interior sum, same side, interior sum. These are going to add up to be 180, right? So like this angle and this angle would add up to be 180, same over here. So angle L and angle M both equal 130 degrees. That's it for example 1. Example 2, find the value of x in the isosceles trapezoid. Okay, so I know this is an isosceles trapezoid. This diagonal is going to be congruent to this diagonal. Now there are two pieces to it, so we are going to have to add these together. So maybe I'll have enough room. Let's see, 5x plus 2 plus 21. And let's make this side green. We got 3x plus 6x minus 5. And we know they are congruent, so we could put an equal sign. Okay, maybe also a little line to do some algebra, because we got algebra to do ahead of us. Okay, so let's just start by adding some like terms together. 5x, 2, and 21. I'm going to add 2 plus 21 together. So I have 5x plus 23 equals 3x plus 6x is 9x minus 5. Okay. I'm going to put some x's together. If I subtract 5x on both sides, I have 23 equals 4x minus 5. And if I add a 5 on both sides, I will have 28 equals 4x. And then finally, just divide both sides by 4. And 28 divided by 4 is 7. Now, I believe this is our answer, but the only way to be sure is to just check our work. So I'm hoping, I see 21 here, I'm hoping this will also be a 21. 3 times 7 is a 21. So checks out there. Let's see, 5 times 7 plus 2. 5 times 7 is 35. 35 plus 2 is 37. So hopefully this will also be a 37. 6 times 7 minus 5. 6 times 7 is 42. 42 minus 5 is 37. So we just checked, x does equal 7. And that leads us to a new concept, midsegments. Recall that a midsegment of a triangle is a segment that connects the midpoints of the two sides. So thinking of a midpoint, we have this side right here. This point cuts it right in the middle, making this side and this side congruent. Same thing over here. This is the middle of this side. We can't assume that the lengths are going to be the same, that like the left side and the right side are equal. It actually looks like this side is a bit longer. So we don't know for sure. So that's why we have different tick marks going on. So on the bottom, it gives us a little bit more detail into this theorem. So it says that a midsegment of a trapezoid is parallel to each base. So we can see these arrows here showing that all of these are parallel. So I'm seeing some parallel symbols. MN is parallel to AB. MN is parallel to CD. So that's what I see. So that's what we just kind of discussed here. Let me grab a different color. Its length is 1/2. So 1/2 the sum, that's where that plus is coming in, of the lengths of the bases. Lengths of the bases. So like AB and CD. If I add these two things up and cut it in half, that'll give me MN. So for example, if AB is 1, CD is 3, 1 plus 3 is 4, 4 cut in half would make this a 2. Okay, so that's very simplistic of an example. Let's go into an example that might be a little bit more complicated than just 1, 2, and 3. Okay, so this one says in the diagram MN is the midsegment, so they're already telling us that this is in fact the midsegment, and they just want us to find essentially the length. So the formula was 1/2, and all we had to do was just add these two things together. So 12 and 28. 12 plus 28 is 40, and half of 40 is 20. And you know what's a fun way to check your answer? If I took this answer and I added 8 to it, 12 plus 8 would get me 20. And then if I add 8 again, 20 plus 8 is 28. So just notice that like this is the midpoint, right? This is the number that is in the middle of 12 and 28. So another way of thinking about it, if you're not like a formula kind of person, if you're like, instead of me dealing with a formula, how can I understand this conceptually? That's another way of thinking about it. All right, this is our final example. So we are going to use this to answer these two questions. If EG is equal to FH, so EG is a diagonal, FH is also a diagonal, is it isosceles? And that's an easy one because there is a theorem for that. And the theorem does say, so this is for 3, yes, this is an isosceles. I know I always forget how to spell it. Isosceles trapezoid, because the diagonals are congruent. Easy enough. Getting into 4 next. If HEF, this angle right here, is 70 degrees, and FGH is this angle right here, is 110, is the trapezoid EFGH isosceles? And explain. Now, I know that these sides are parallel. And so what that tells me is that this side and this side being parallel, this line is making these two angles supplementary. So that would make this angle 70, and the same can be replicated on the other side. I've got these two parallel lines. This connecting side makes these two angles supplementary. So that would make this 110 as well. And so based off of this idea of supplementary, or you could say consecutive interior angles or same side interior angles, we could see that yes, this does check out to be an isosceles trapezoid. So let's say yes. The base angles are congruent. The base angles are congruent. So this is let me check. I always forget how to spell isosceles. This is an isosceles trapezoid. All right. Now you can go on to your practice. Good luck.